But it's just like an indispensable tool. You know, if you become a statistician, you probably use a computer rather than your calculator. But we don't want to buy that kind of an expensive statistical package, and you're still going to have to learn stuff. And the things that you're learning here with your calculator are going to be there's lessons involved in it that will also be appropriate for when you're doing stuff with computers, any kind of data. So before I start on this, I sent out an email and I asked you guys, and so I'm just repeating it verbally, to download the data for topic 9. Okay, so you'll be able to see it. It's in an easy load folder there in lessons, topic 9, easy load. Download those files into your calculator also, at some time, before, well, maybe before Thursday. Yeah, that would be good. It shouldn't take you very long. I think now you've kind of got the hang of it. All right, so do you remember this is the rowers. These are the Olympic rowers. And this was the histogram, or the dot plot, so to speak, of their weights. And if I remember properly, we said that this was a skewed left distribution, which I think is probably pretty accurate. I'd say that is a skewed left distribution. Okay, well, let's make a histogram of the rowers' weights. Okay, we didn't do that yet, did we? We didn't do, okay, great. Okay, so get your calculator out, and so I'm gonna go second stat plot. Who by the way does not have a calculator? Everybody's calculator ready today, huh? Good, okay. So second stat plot, and I'm going to start with number 4 to turn all the plots off so that I can just make sure I don't have any conflicts. I like to start that way. And then I'm going to go back to second stat plot, and I'll put this plot in plot number 1, and I'll turn it on. And I can see that the type I already have is highlighted is the histogram. So that's pretty good. And so I can scroll down to the X list. And for the X list, the file is called rowers 08. So I'm going to go second list. And I have a big list of files in there now. So if I want to kind of get closer to the rowers one, I can go alpha and then look for the R, which is right above the multiplication sign, and it'll take me to the R's. Did I show you guys that yet? Or is this a first? Okay, so if I want to kind of get down the list quickly, if I have like a whole bunch of files in there, alpha, and then you look for the R, which is in green, and it happens to be of the over the multiplication sign, and it took me right to the R's, and it turns out that that's the only R that I have. So that's rower's weight, and I press enter. And I have to press enter again. So now I have everything set up to be able to do my histogram. So I'm going to go zoom 9. But again, when I push zoom, this thing pops up on the bottom sometimes. So I just have to clear it and then go zoom 9 again. And I get a histogram. And I would say that this histogram right here looks close enough to this dot plot that I'm pretty comfortable that I've got my data in there correctly. How are we doing? Are we stuck anywhere on the pushing the buttons? Everybody's okay with this so far, yes? Okay, all right. Well, I do want to investigate this histogram some, so I'm gonna go to my window, and I see that my X scale here is 18, which is not a very comfortable number. And my minimum is 121, which is also not a very comfortable number, right? So if I was to kind of go back and look at my histogram and I would do trace, I would see, well, my first bin is 121 to 139. And then I have a bin from 139 to 157. And then I have a bin from 157 to 175. So those aren't going to fly. Those are not good numbers. So I'm going to go back to my window. And I think I'm going to make my X scale from 18. I think I'm going to bump it up to 20. And then if you remember, your minimum has to be evenly divisible by your scale. So I'm going to go down to 120. And then my maximum also has to be evenly divisible by the scale. So I think I'm going to go up to 260. And now I'm going to graph it. And I think that's a little bit nicer looking histogram. How are we doing? Are we okay? Are we okay with that? All right. All right, I'm going to do one more thing, which I just thought of here. I'm going to make, just for the heck of it, I'm going to make my X scale 1. And I bet that what I'm going to get is going to look like identical. Nah, that's too small. I can't do it. It won't let me do it. So forget that. That was just me playing. Okay. So what we're going to learn now is we're going to learn how to use a calculator to find mean and median. And I think we did that before, but we're going to do it again, right? We've done that once before. Yes? Okay. So let me quit out of this. So I want to find the mean and the median for the entire team. So I press Stat. And then up on the top, I have this menu Calc. I want to scroll over to the Calc menu. I want to calculate some statistics. And I'm doing one variable statistic. So I'm going to press 1. And then it says, okay, you want some statistics, but what do you want it from? And I say, well, I would like it from the rower's weight. So I'm going to go second list, and then alpha R, and there's my rower's weight. So I'm getting my one variable stats on the rower's weight, and I hit enter. And I find out that my mean, my X bar, is 100. Oh, it went away. Wait a minute. Bring it up here again. Is 197.96. So my mean is 197.96. And then if I want the median, I just need to scroll down here and I see that my median is 205. Pretty good?
Mr. Jenkins?
Yes, please.
Could you get like the numbers into the list? Because I have it set up where I have like the rower's weight in list 2, but what do I do after that?
Okay, so if you want the rower's weight into list 2, you need to show me your calculator again, Brooklyn. Let me see it one more time. Yeah, okay. So can you, well, press enter and it's going to give you an error.
Yeah.
Okay, so you need to highlight, you need to have the cursor on the L2. So all the way up to the top. Okay, now press enter. And then if you look at the bottom, it's going to say L2 equals, and then you're going to have your cursor flashing, right?
Yeah.
Okay, now go a stat list and look for your rowers list.
Yeah.
And then press enter.
Okay.
And is all the data there now?
Yeah.
Yeah. Okay. Now that's actually something we're going to teach you. So you're actually, I'm going to go do that right now with everybody. So most of you, when you got these statistics that we just did here, used the rower's weight list, the RWGHT list, right? Okay. So the next question says, well, I would like to know what is the mean and the median of this data, but without the coxswain, without the lightest person, okay? So the way I do that is this. Well, I'm gonna show you the way not to do it, okay? And because I want you to understand really what we're trying to do here. So I can go stat edit, and And I have these lists of data, the list 1, list 2, list 3. Now what you're looking at right here is a data editor. So just like a word processor, you know, you can copy something into your word processing document, and you can delete words, and you can retype them, and you can edit it, right? Well, that's what we can do here. So the wrong thing to do is what I'm going to do right now. So if I go up here to L1 and I go, you see above the delete key, it says insert, INS, right? So I can go second, insert, and it makes me a brand new column. And I can say, okay, well, down here at the bottom, it says, what's the name of that column? Well, I'm going to name that column. I'm going to go second list, and then alpha multiplication sign. I'm going to name that rower's weight, and I'm going to hit enter. And now I have all the data for the rower's weight right in there, right? Is everybody okay with that? Okay. Well, now if I decide, they say, well, without the coxswain. So I'm going to go down here because I know that the coxswain weighs 121 pounds. He's a real skinny dude. There he is, 120, 121. And I could just delete him, right? And then redo my statistics. Yeah, but the problem is if I delete him in this editor that it is now editing my rower's weight data, now the coxswain is permanently eliminated from that data. And I can't use it again. I've tainted the data. I've soiled the data. And I don't want to do that. I want my rower's weight data to be correct. I don't want to mess with it. Is everybody understanding what I'm saying here? Right? I don't want to go in there and edit it. I want it to be like it is. So what I'm going to do is I'm going to go back up here to rower's weight, all the way up to the top. And I'm gonna delete this. Now, I'm just deleting it in the editor. I'm not changing any of the data. I'm just deleting this in the editor. And what I'm gonna say is, okay, L1, I have some data in here, and I don't even remember what it's from, and it's certainly not the data that I want right now. So I want my rower's weight data. I wanna make a copy of that and put it into L1. So I've highlighted L1, and I hit enter, and you see now I have L1, and down here at the bottom, it's got all the L1 data except that it's in what's called an array as opposed to a list. But I don't care about that data, so I can just press clear, and I've gotten rid of it. So really, if I hit enter right now, all that data is gone, right? I edited it away. So I'm going to go up to L1. I'm going to hit enter, and down here it says L1 equals, what does it equal? Well, I want L1 to equal my rower's weight. So I go to find my rower's weight list right now, and I hit enter, and it says, okay, you want L1 to be equal, to be the exact same thing as the rower's weight. Hit enter, and bingo, there's my rower's weight data, right? And I can do anything I want with that data now. I can delete things, I can add things, I can change things, which we're going to do in a minute. And my rower's weight data is still safe in the calculator. I'm just messing with a copy of the rower's weight data. Am I making sense? Anybody need me to repeat that? I'm happy to repeat it. No, everybody's okay. All right, great. Well, so I'm going to ask Magic Ball. If I remove the coxswain, so I'm asking Juliana, if I remove the coxswain from this data here, what's going to happen to the mean? What's going to happen to the mean of the team weight?
Is it going to become smaller?
Well, the coxswain's the lightest guy. So if I remove the lightest guy, what's the average going to do?
Go down, right?
Now let's think about it here. Okay, so I am in a I'm in a room with 3 heavyweight champions of the world. No, with 3 offensive linemen from the LA Rams. Okay, those are like big guys, right? I mean, they're like 300 plus pounds, which is kind of astounding, really, when you think about how fast they can move. But so if we average all of the 4 of our weights, it's going to come out to some number probably in the high 200s. You with me, Juliana? Right? If I remove me, the lightest guy, what's going to happen to the average weight? Is it going to go up or down?
It's gonna kind of stay the same because the light guy like doesn't really matter as much. Like it's gonna go down though, right? I mean, well, it's gonna go up. Sorry, it's gonna go up.
It's going to go up. Do you see it now? Is it making sense? Does this make sense to everybody? If you remove the lightest person, then the average is going to go up. Yes? If you remove the smallest person in the room, the average height goes up. Right? So I want to remove the coxswain, right? So there's two things I'm going to do. First of all, I happen to know that his weight is 121, and I could scroll down and find it. But if there were like 1,000 data items in this list, that would be very difficult to find. So we're just learning all sorts of things about the calculator here. What I'm going to do is this. I'm going to press my stat button. And you see number 2 is sort ascending, and number 3 is sort descending. Right? So if I sort this list in ascending order, that means the lightest guy is going to be at the top, and then it's going to get progressively heavier. It's ascending, getting heavier. Am I making sense? So I'm going to press 2 for sort ascending, and it says, great. You'd like me to sort this ascending, but what do you want me to sort ascending? There's all sorts of stuff in this calculator. Well, I want you to sort second 1. I want you to sort list 1 in ascending order. And when I press enter, it says done. And I say, okay, well, let's see if it's really done. Stat, edit. And sure enough, I have my weights now sorted from lightest to heaviest. Does that make sense to everybody? Yes? Is there a question? Somebody asked me a question. I'm happy to do this again.
Wait, I think I did one part wrong because when I did sorting and like ascending, I accidentally did the list, like the actual, like, I don't know.
The actual data list?
Yeah.
You didn't do L1, you did the rower's weight?
Yeah.
Yeah, you see, so you've kind of messed up your data a little bit there. Not so much. That one's not so bad because all the data is the same. It's just in a different order, right?
Yeah.
So I wouldn't worry about it. But if you did that, and like mess with it a little bit, well, then you got to go back to your source and re-download the data.
Okay, but now can you repeat how to get back to the, like, how do I sort it? I don't remember how to get to the
Yes. Okay. So did you have the rower's weight data in L1?
Yeah.
You do. Okay, great. So I want you to go stat and then sort ascending. So number 2, and it should say sort A, right? And then if you push the second button and then go down to 1, you'll see the blue L1 is right above the 1. Do you see it on your calculator?
Yeah.
You press that and then close your parentheses and hit enter. And now when you go back to stat edit to look at your list, it should be in order now.
Okay, yeah, it is. Okay.
It is?
Yeah.
Okay, good, very good, very good. Okay, so now I know who the lightest guy is, right? He's the guy at the very top. So I'm just gonna press my delete button. He's highlighted. I just got rid of him. He's now deleted. He's off the list. He is no longer there. Okay. So I want to find out what is the mean and the median without the coxswain. So I'm going to go stat, calc, 1 variable statistic, and the data is still in list 1. So I'm going to go second 1, and I hit enter. And I find out that without the coxswain, the mean of my whole team has now increased to 201.17. 201.17. So you see, Juliana, the weight got heavier because I took out the lightest guy. Now the weight of the team is heavier. Well, let's see what, and considerably heavier, like 4 pounds heavier. Let's see what happened to the median. Well, the median also went up to 207. not as much, but it still went up, right? Because we took away one of the elements there. Everybody still following? Yes? Okay. I want to put the coxswain back in. Okay, so there's two ways I can do it. One is I can just reload my data. But the other way, I'm going to show you another way to do it. So I know the coxswain weighed 121. So I'm going to go stat, edit. And you see I've highlighted 154 right there. Everybody with me there? Okay, if I'm highlighting one of these data items, any one of the data items, I can go, in fact, I'm going to pick a different one. I'm going to pick like 161. And if I go second insert, it puts in a new data line and it fills it with 0, right? So I just go 121 and hit enter. So I've put the coxswain back into the data. Am I going too fast, or are we still, everybody okay? We're still good. Okay, all right. Well, now it's saying, well, what is it going to be if the maximum weight was 329? Well, I have to find, well, what is the maximum weight? So I'm going to go stat. This time I'm going to sort descending. So my heaviest weight is at the top and it gets lighter going down. So I'm going to press 3. And I want to do that with my list 1. And I hit enter. Now I'm going to look at my list. And my heaviest guy now, who is 229, now he's at the top and it's in descending order. So if I actually went to the bottom of the list, which I can do by actually kind of going up and then it goes around. So I'm going to go up to L1 and then one more up. I can see the bottom of my list is 121, which is a coxswain. That's the lightest guy. But I want to go back to the top here, and I want and it's saying what happens if the maximum weight instead of being 229 was 329. Other than the fact that they would lose the race because they got an extra 100 pounds to row, right? What happens to the mean? So let's ask a question here. And we're asking Alexi. Alexi, if I make the heaviest guy 329 instead of 229, is the mean going to go up or down?
I feel like the mean would go up.
And I think that is correct. Let's find out. So I'm going to change this. It's highlighted. So I'm going to go 329 and hit enter. So now that's 329. And now I'm going to go stat, calc, one variable statistics. I'm still doing L1. I hit enter. And my mean is now 201.96. All right, so now my mean is 201.96. We added 100 pounds to the whole team, and the mean has gone up from 197 to 201. The mean went up. The whole team's mean went up. Well, let's see what happens to the mean. Now I'm going to ask somebody, what's going to happen to the median? This is a good question. Abby, what's going to happen to the median? I'm comparing it to this one, to this one here, the whole team. I've increased the heaviest guy's weight from 229 to 329. The mean went up. What's going to happen to the median?
Would the median go up as well?
So how many people think the median is going to go up? How many people think the median is going to go down? How many people don't know? How many people think the median is going to stay the same? I think that's the right answer. Let's think about it, Abby. So we know that my lightest guy is 121, right? And then there's like 154 and blah, 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 blah. There's something that's in the middle there, and then blah, 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 blah. And there was like 225 and then 229. So the value in the middle was this one right here. Are you good with that, Abby? Okay, now if I change this here to 329, does that change at all?
Oh no, it'd be the same.
It doesn't change. The value in the middle is the value in the middle, right? I can change any of these data items at either extreme, and the value in the middle is going to still be in the middle, right? So let's take a look and see if that's true. Scroll down here. And sure enough, the median still stayed 205. Okay. Now they're saying that the typists that put the data in, so let's go back here to my list, stat 1. Can you see why it's really nice that we can edit this in like a copy as opposed to using the original data? I mean, if we were using the original data, we'd always have to be worried that I put it back in right, and then maybe you forget something. But if you're doing it on a list like this, it really doesn't matter what mistakes you make, because you can always just bring the original data back into the list. Okay, so Brooklyn. They're saying that they made a typo when they entered in the heaviest guy. And instead of going 229, the data entry person had a hiccup and put in 2,229, right? So they made this person like, it was like the person plus his horse, you know? And so what's going to happen to the mean compared to the whole team if we make that change?
It's going to go up by a lot.
I think it's going to go up by a lot. And what's going to happen to the median?
It's going to stay the same. Is it changing it? Yeah.
Pardon me?
It's going to stay the same.
Yeah, I think so. So I'm going to change this to 2. Oh, wait, I'm in the wrong spot. Here, I'm over here. 2229. Okay, so now, and it's clearly a mistake. Come on over here. Get rid of this. Oh, stop. Just go away. All right, never mind. So I'm going to go stat, calc, 1 variable statistics. I'm still editing L1. I hit enter, and I find out, well, my mean has gone up quite a bit, 277.96. 277.96. And my median stays the same at 205. So this is telling us something very important. This is telling us, first of all, if we have an outlier like the coxswain, right? Or like a typo where the person weighs 2,000 pounds instead of 200 pounds. If we have an outlier, that outlier is really going to affect the mean that we come up with. It's going to affect the mean, but it's really not going to affect the median, maybe a tiny bit, but not that much. The other thing that it's telling us is that if I have a distribution that is skewed, so here's a skewed right distribution. A skewed right distribution has some values way over here at the high end that could be really a lot higher than the bulk of our values right in here. So a skewed distribution is not going to have a very accurate mean. A skewed distribution is not going to have a very accurate mean. Now, a symmetrical distribution, well, we'll find that the mean is going to be like pretty much right in the center because we're averaging all the weights that are lower and all the weights that are higher. And since it's symmetrical, we got the same number of higher weights as we do lower weights, and they're the same distance from the middle, right? So in a symmetrical distribution, the median is going to be pretty good. So what I'm going to show you right now is a little chart that I use. And okay, we have distributions that are skewed, and we have distributions that are symmetric. Now, I would copy this chart down as we're going along here. Maybe, I mean, at some point you need this chart. I think you'll find it helpful. And we have measures of center. We have the mean and we have the median. When you have a distribution that is skewed, you never use the mean. The mean is irrelevant when you have a skewed distribution. It's going to pull it to one way or the other. It's not going to be a very helpful statistic. When a distribution is skewed for the center, you always use the median. If the distribution is skewed, you always use the median. If a distribution is symmetric, you always use the mean. And you can use the median. Sometimes it's nice just to have the median in there as your information, but you will find in a symmetric distribution that the median and the mean will be very close together because we have about the same number of data items on one side as we do on the other side. So if I ask you to describe the distribution, I give you some data and I say describe the distribution, you really have to make a histogram because the histogram is going to tell you whether the distribution is symmetric or whether it's skewed. And if it's skewed, then you're going to use the median. If it's symmetric, you're going to use the mean for the center. So that should make some logical sense after having gone through these problems. Does it make some logical sense? Is there a question about it? Somebody asked me a question. I'm happy to take a question here. No questions. We're pretty good on this. Okay? All right. Then let's see what happens next. Okay. So we have a term now that a measure whose value is relatively unaffected by the presence of outliers, we say it is resistant to outliers. Okay, so which is resistant to outliers, the mean or the median? Alexis.
Would it be the median?
Yeah, the median is resistant to outliers. We saw that. We had an outlier that weighed 2,000 pounds, and that outlier didn't affect the median at all, right? It had a huge effect on the mean, right? But so like, and I've used this example before, but like a lot of times in a neighborhood, housing prices can be skewed. Or there can be like a big outlier, like in my neighborhood here, you know. So I live in a neighborhood that is an HPOZ. Anybody ever heard of an HPOZ? HPOZ. It's a historic preservation overlay zone. So the houses in my neighborhood are basically, you can't do anything major to the house that's going to change the architecture of the neighborhood. So I'm sure you've seen in a lot of neighborhoods where they tear down these older houses and they build these big giant boxes. You know what I'm talking about, right? I hate that, but they do it, and that's the way it is. You know, they can't do that in my neighborhood. But somebody just built a house in my neighborhood, and the house, although it's maybe a little bit larger than the typical house in the neighborhood, you know. The architectural style is pretty much the same, except that they actually dug a like probably about a 2,000 square foot basement. I mean, the basement itself could be a house, you know, and we were watching them, you know, dig this giant hole, right? So this house is going to be an outlier in my neighborhood. You know, I mean, it'll sell for like twice the price of any other house in the neighborhood because it's got like twice the square footage, right? So what is the, if somebody wants to say, well, the average price of a house in this neighborhood is such and such, well, they have to use the median. They don't want to, I don't want them to use the mean, because the median is the one that's going to give kind of more of an accurate figure, because this one house is a huge outlier. So be very careful when you're reading something that's talking about the average this or the average that. In fact, if you're ever in a class or in a lecture or something like that, and somebody says the average this or that, your hand has to shoot up immediately. And you say, I learned in my stats class, what are you talking about? Like mean or median, you know, and put the person on the spot, because it is used very deceptively all the time. Am I making sense here? Yes. Okay. All right. All right. I said this skewed when it's symmetric, we use the mean. I gave you the little chart. That was good. Okay. All right. So what I'm going to do right now for a second is I'm going to stop the recording. Because I thought that was a pretty good explanation of how to use your calculator to calculate statistics. So I'm just going to stop that right now. And if I can.